Okay, today we're starting lesson 42 finally, and we're going to be talking about conic sections. And conic sections I can't draw very well, so I'm showing them to you in the book. And when we're talking about conic sections, remember we're talking about slices of a cone. So here they're showing a picture of a conic section that results in a circle where you slice the conic cone straight across the cone, and it is perpendicular to the axis there. And then over here we're talking about a slanted slice, which results in an ellipse. And then down on the bottom, let's see if I can get this down there, they have a nice little parabola, which is a slice through the top of the cone. And they're showing you what they mean by a conic section. And then they've got down here the cone that is being sliced vertically through two of the cones, and it's showing a hyperbola. So when we start talking about these figures, and they call them conic sections, you can see why they're calling them conic sections, because they're made from slices of a cone. Okay, so what we're doing now is we're going to be working on specifically the circle, which is a conic section, that when you draw a cone, okay, they always make their cones here, but here's a cone and here's a cone, and a circle will result when we make a slice completely perpendicular to the axis of the cone, and that is a circle. Okay, so we're talking about circles today, and we know from Algebra 2 and other things, but we know that when we have a circle that has a center of 4, -6, and a radius of 5, that we can write that circle in standard form, and the standard form of the circle is x minus h, where h is the x value of the vertex, plus y minus k, those are squared, both of those are squared, k squared, and k is the y value of the vertex. So we'll just put over here vertex is hk, and then r squared is at the end of the formula. So that is the standard form of the circle. Now what we're doing now with this problem over here is we are putting this equation first in its standard form and then in its general form. Okay, so the standard form is going to be x minus the x value of the vertex for quantity squared plus, okay, and then we're going to have the y minus the -6, okay, because it's a minus that value, squared is equal to r squared, or 25. Okay, so normally we wouldn't write this like this. We just have x minus 4 quantity squared plus y plus 6 quantity squared is 25. And that is the standard form of the circle. Now we're going to put this same standard form, the same circle, into its general form over here. And the general form is going to happen when we multiply all this out. Go ahead and FOIL it. And then we always have a 0 on one side for that general form. So we're going to multiply this one out, and we're going to get x squared. Remember, when we square a binomial, we always get a trinomial. Okay, so it's going to be x squared. This product doubled, so it's going to be -4x doubled, or -8x. This one squared is a positive 16. Then we move over to this parenthesis. We're going to have a y squared. We're going to take this product, 6y, and double it to get 12y. And then we're going to take this 6 and square it, 36. And then we're going to take the 25 and slide it over, -25 is 0. Okay, now normally in standard form, we're going to put it in descending order of the variable. X is first and then y's. So it would be x squared and then the y squared plus y squared, and then the -8x and the plus 12y, and the plus 16, oops, let's see, plus 16 and plus 11. So this becomes 11 and a 16, so a 27 equals 0. Okay, so that would be our general form, and that is correct. Okay, so now we're going to do this again. I'm going to move this one over here. See if you can see my other problem, which is also in your book. But now we're going to do the same thing with a circle of radius 4 and a center -3, 3. So we're going to go from the standard form to the general form. So the first thing we should do is write the standard form down, which of course is up there with the equation. So we're going to write here x minus the x value of the vertex, a -3, quantity squared, plus a y minus the y value of the vertex, 3, quantity squared, equals the radius squared, 16. Okay, so that's a pretty good standard form. Excuse me. That's a pretty good standard form, but I'm just going to go ahead and take this minus a minus out and clean it up a little bit. So there's my standard form of this situation here with a radius of 4 and a center of -3, 3. So now I'm going to turn this into the general form, which means I'm going to have to foil this one, get this one on the other side so that there's a 0, and I can turn it into general form. So when we foil this out, we're going to get the first one squared, x squared. This product, 3x doubled, is 6x. And this last one squared is 9. Then we come over here and we do y squared. This product, -3y doubled, is -6y. And then a plus 3 squared is 9 equals 16. But because we're trying to get it to general, we'll do a -16 is 0. Okay, I hit the wrong button there. So now I'm going to need to get things in the correct order. So we're going to put our x squared first, and then our y squared, then our 6x minus our 6y, and then a plus 9, and a plus 9 is plus 18, minus the 16 is a plus 2, is equal to 0. Okay, so my completed equation in general form is x squared plus y squared plus 6x minus 6y plus 2 is equal to 0. And now I'm done.